statements column, you're going to have two statements that contradict each other, and that's what we want. All right. The steps are down here. If you ever get lost, I don't think you will, but if you ever get lost doing your homework, if you do your homework at all, their steps are right down here. Too soon, too harsh. Sorry. Suck it up. I gave you like 3 problems last night. All right, number 1, let's jump right into the fire. Instead of reading over those steps, let's jump right into it. Give or take, we've done about 100 problems, 100 proofs so far this year, give or take, about 100. Something's happening in this proof that we've never seen before. What is it? There's something in this proof that I've never asked you at all. We've never seen in a proof, any of the 100 we've done. What is it? Spence? Yeah, look at the proof statement, everybody. We've never had a proof statement like this. And this proof statement, proving something's not happening, that tells me right away this proof has to be done in an indirect method. All right. So once I see in the proof statement something's not, I want something to prove something's not happening, I got to do this indirectly. I have to do this indirectly. All right, so how do I do an indirect proof? Well, you see the first step, nothing's changed, right? I got my givens, and everyone sees it's in a statement's reasons. That hasn't changed. Here's where it's going to change. Your second step now. Your second step is going to be what we call our assumption in this proof. Our assumption. And what are we going to assume? The opposite of the prove statement is true. What is the opposite of if we're proving A not equal to C, what would be the opposite of that statement? Opposite. 11. Saying A.
Is not equal to C.
Well, that's what we're saying. So what's the opposite of that? That's what we're going to assume. The opposite of the proof statement. Everybody good. You assume the opposite of the proof statement is true. That is always our assumption. Take your proof statement, say the opposite is true. Now I'm going to kind of lead you through here, and then next proof I'll start calling on numbers. Watch what this does to us. This is going to put us in a real bad spot. I want you to focus on these 2 overlapping triangles for me, BAE and overlapping triangle BDC. I want you to focus on those 2 in this proof. Our assumption said A is congruent to C. Also in the givens, what did we know? AB and BC are equal. See those 2 sides? AB, BC are equal. Can you guys get those 2 triangles congruent for me? We're almost there. I got a pair of sides in the givens, and my assumption gave me a pair of angles. Can anybody find anything else? This isn't new, by the way, what I'm asking you to do. Proving these triangles congruent. This is not new. I got a pair of sides and I got a pair of angles. Find something else right now. Find something else that we can say is congruent. So I can say the triangles are congruent by this method. Find something else. Find something else. And I'm going to call on somebody here because this is not something new. What else can you tell me is congruent between those 2 overlapping triangles? Anything else here? 7?
Angle B is congruent to angle B.
There you go, Karen. Angle B congruent to angle B. Good work. Where is he going with this? You'll find out in a second. Now, can you tell me what method, by what one of those 5 methods we discussed last unit, why those 2 triangles are congruent now? I have 2 pairs of angles on a side, so it's either going to be angle, angle, side, or angle, side, angle. So let's make the triangles congruent. Triangle BDC. Congruent to, if I go BDC, how do I have to name the next one there, kids? BDC and looks like BEA. All right, what's the method going to be here? I'll call on somebody. Is the side in between or not? And if you can't see it, draw it out. If you can't see it, draw out one of the triangles and mark angle BA and the side and see if the side's in between. Got a method here? Either angle, side, angle, or angle, angle, side. What do we think here? 3?
Angle, side, angle.
That side is in between, so it's going to be angle, side, angle. All right, where are we going with this, huh? Is everyone all right proving the triangles congruent? All right, so last unit. Here we go. Let's review again. If the triangles are congruent, what else do we know now? What else do we know now? If the triangles are congruent, so are, Anna?
All the sides.
And all the angles, right? Everyone agree? Everyone remember CPCTC? If the triangles are congruent, so are all the sides and all the angles. Whoa, wait a second. All the sides are equal? So in my yellow triangle, BD would be congruent to what side in my orange one? BD would be congruent to which side in my orange one? BE? Right? By? Why is that true? CPCTC? And you're pretty lucky right now your paper's not catching on fire. You're pretty lucky. It should be bursting into flames right now. Are you serious? You serious with that? Why am I saying this? We just wrote down BD congruent to BE. You serious? Why is that a huge problem right now? Whether it be up on the board on my proof or on your paper right now. This right here is a huge issue with me right now. I can't believe we just wrote that down. Why is that an issue? Go back on the very top. At the very top, Anna, what were we told?
It's in the givens that they're not congruent.
We were told that this is true. BD is not equal to BE. This is true. Hey, they can't happen at the same time, can they? Can they happen at the same time? Absolutely not. So I'm going to go slow here. Is this a true statement? No, because that one was. This is false. But wait a second. This is false. What led us here? Even before then. What started this whole journey to get to BD equal to BE? That we assumed A was equal to C. So is this true? No. So if this is false, what's got to be true then? The opposite, which is A is not equal to C. All right, let me back up and go through that a little slower. We're all in agreement this is false because we were told that they're not equal. This is false. So that means what else is false? Whatever started this whole thing, which is our assumption. If this statement's false, that's got to be true. Yes? And that's called an indirect proof. So now we're going to say, all right, we have a contradiction, which we know is false. So now A is not equal to angle C. And here's our final reason in every indirect proof. Assumption, which we started with, our assumption, led to, what did it lead to? What did it lead to? Which is a what of this given? Contradiction. So assumption led to a contradiction. And there's more though. Not another step, but something else I'm going to require. So I know you know what the heck is going on. Show me what steps, list what steps the contradiction is in. So we had BD not equal to BE in the given, step 1, And what line did we contradict it on? Step 5. So I need 1, 5 next to that to show me this is where your contradiction is. You're always going to contradict one of the givens. All right, so let's sum up where we're going with this, because this took us a while. You always assume the opposite of the proof statement. There's statement 2. Opposite of the proof statement. And then you are going to contradict one of the givens. That is where your contradiction is going to come from. One of the givens will always be contradicted. You're going to say the opposite of it. Anything you want to ask here? I'm going to contradict one of the givens. We're good? All right, one more together, and then I'm going to let you go on your own with one. How do I know this one's going to be done indirectly? What's there that what do I read that tells me, hey, you better do this proof indirectly? 8, 12.
Because the proof is saying it's not.
Good. Anytime I have not in the proof statement, it's going to be done indirectly. So I write my givens down. They're all in there for you. Now you write your assumption. What are we going to assume is true about this proof? You got to know where to get it from. What am I going to assume is true about this proof? 9.
BD bisects AC.
You go to the proof statement and you write the opposite. Hey, the proof statement. You write the opposite of the proof statement. So BD bisects AC. And now you really treat that like a given. You could treat that like a given. All right, before we move on in the proof, figure out what you're going to contradict. Look at the givens. You have 2 of them, right? 2 givens. Which out of the 2 do you think it's going to be the easiest to say the opposite of or contradict? ABC is not isosceles. Can we contradict that? Or can we contradict BD as an altitude? Which one do you think it's going to be easier to contradict? And remember, when I say contradict, you have to prove the opposite is true. What is it easiest to prove where the opposite is true? What do we think here? You have 2 givens. ABC is not isosceles. Okay, what would contradict ABC is not isosceles? Can we prove something's isosceles in here? Okay, so you're always going to contradict in the givens the not one. So here's what you need to do. Somewhere in your statements, this has to be said. ABC is isosceles. That's what's got to be said somewhere in your statements. And I think you guys can be able to do that from last unit. Prove ABC's isosceles, you have a contradiction. How do you show a triangle's isosceles? 1 of 2 ways. Talk to me. 2, how do I show its isosceles?
You can prove 2 angles.
Or 2 sides, either one. Get me there. Here we go. Show me 2 sides or 2 angles are equal in triangle ABC. So something you want to throw down right now, either from the givens or the assumption about this proof. Here we go, 5. Start us off.
BD is an altitude.
Yeah, I got that. That's given. I don't have to write that down.
BD is a right angle.
A segment is a right angle?
Oh, no.
Okay.
BD is equal to BD. Wait, no.
You could write that. Why don't I write? That's fine.
It's like one triangle though. Wait.
But what are we trying to do, though? We're trying to prove either these 2 are equal, right? Or these 2 are equal. And the only way we do that is if the triangles are equal.
Oh.
Agree?
Yeah.
So that's where I'm trying to push you guys is, yeah, we're going to try to prove the triangle isosceles, but we're not going to do that unless these 2 triangles are congruent. So I'll take your BD equals BD suggestion.
Okay.
All right? That's the only way I'm going to prove this isosceles is if the 2 triangles are congruent. Okay, BD equals BD. What else you got for me is true? 12.
Angle BDA
Yep.
is a right angle, and you could also say BDC is.
Perfect. Yep. Rachel notices a vocabulary term. We've talked about this unit, and she knows what it does. Angle BDA and angle BDC are right angles. And I realize that usually we'd write perpendicular lines form right angles, but I don't have perpendicular lines. What do I have instead that Rachel noticed? How did we know they're right angles here? I don't see any perpendicular symbol up here, so how did we know they were right angles? 6, altitude. So we could say definition of an altitude, or altitudes form right angles. I just can't say perpendicular lines form right angles because I don't have them here. So we had to know what an altitude was. This is going to be a long one, by the way. This is a 10-stepper, so buckle up. Okay, what else? Still looking. 7.
A, B is congruent to BC
Why?
because they're across from, or no.
They got to be in the same triangle, right?
Yeah.
And these right angles are in 2 different ones, so I can't use that.
Would you say BDA is congruent to BDC?
Right? That usually comes right after I say they're right angles. So BDA, congruent to BDC. What's your reason there, Kara?
All right angles are congruent.
Good. All right, so I got a pair of sides. Kara just gave us a pair of angles. I'm looking for one more pair to say the triangles are congruent. And remember, your assumption acts like a given. You're assuming this is true, so use it. If BD bisects AC, that tells me 4. AD, DC, congruent. Definition of bisects. Good. And then that gives me a side. So I think the triangles are congruent now. Just make sure you write them in the correct order. Method. 2.
Side angle side.
Yep. Okay, how does that help us get it to be isosceles? If the triangles are congruent, how do I connect it to be an isosceles now? If the triangles are congruent, what else are congruent then? 6.
All the sides and angles.
So pick a pair I'm going to need here, Nate.
Angle A.
All right, we can go angle A congruent to angle C. We could go AB congruent to BC. Either one would be acceptable in this next step. So I'll take Nate's suggestion, A congruent to C. CPCTC. Whew. Now what do I have? Now what do I know about triangle ABC? It is just prove these 2 equal. So now what do I know about triangle ABC? 5. It's isosceles. This is where your paper catches on fire because you're writing down a contradiction right now, aren't you? You just told me it was not isosceles in the givens. Now it is. How do you know it's isosceles? For 9, how do we know this is isosceles? Where's 9? How do we know it's isosceles? Look at all the work we just did. What did you just write in step 8? Well, no, even in the statements, what did we write? So why does that make triangle ABC isosceles? In a triangle, 2 angles, what about them? 2 angles congruent implies I have an isosceles triangle. Yep. Whew. You guys have a contradiction written down? You do? You have two statements that contradict each other? Yes, you do. The givens in step 9. So that must mean your assumption is false, meaning the opposite is true. BD does not bisect AC. Once you have that contradiction written down, the assumption's false. Opposite's true. So assumption led to contradiction. What lines is your contradiction on? What lines are your contradiction on? 6, we contradicted the given step 1 with what step?
9.
There you go. Questions? Okay, start working on the next one. I'm going to write the proof up here on the board, and you can check it when you're done. Okay, so start working on the next one. Real quickly, so we are all on the right track. Out of these 3 givens, which one are you going to try to contradict? You have 3 givens. Which one are you going to contradict? It's always easy which one you're going to contradict. The not one. You always try to contradict the not one. So what are you going to say? That you're going to try to prove that AB is equal to CD somewhere in your proof. That's what you want. AB is equal to CD. Only way you're probably going to do that, get the triangles equal or congruent. Looks like 9 steps.